Hello everyone, in this video let's discuss how to solve the adjacency matrix problem in graph theory. So, if you see the matrix representation of graph concept, it will be having two types of representation. One will be using the adjacency graph and another one will be using the incidence graph. So in this video, let's discuss how to write the adjacency matrix and how to convert the given adjacency matrix to graph. Both of them let's learn. In next video, let's learn about the incidence matrix. So in this topic, they can give two types of problem. One, they will give the graph and tell you to write the adjacency matrix. Or they will give the adjacency matrix and tell you to write the graph. So let's solve both of them. So first I am taking two problems which are related to conversion of the graph into the adjacency matrix. Now if you see here, I am having V1, V2, V3, V4. So total 4 number of vertices are there for me. So V1, V2, V3, V4. Next, same will be taken this side also. V1, V2, V3, V4. Now, adjacency means neighbor. Adjacency means neighbor. If you see here, from V1, there is direct connection for V2 and there is direct connection for V4. There is no direct connection to V3, and if there was a self loop for V1, we should have written the V1, V1 was also having the direct connection. But if you see here, no self loop from V1 to V4, V1 to V2. So only two possible paths are there. From V1 to V2 there is a path. From V1 to V4 there is a path. So other than that nothing is there. So I will put 0. Same apply for V2. So V1 is over. Now let's apply for V2. From V2 you can directly go to V1. You can directly go to V4. You can directly go to V3. But you can't go back to V2 because there is no self loop. So from V2 you can go to V1, you can go to V3, you can go to V4, you can't go back to V2. So V2 is over. Now V3. From V3 you can go to V4 or you can go to V2. You can't go to V1 because there is no direct connection and there is no self loop for V3, so you can't go back to V3 again. So from V3 I can go to V4, from V3 I can go to V2. Other than that, no other possible paths. So last only one is left, that is V4. From V4 I can go to V1. From V4 I can go to V2. From V4 I can go to V3 because all the paths are having the direct connection. So from V4 I can go to V1, V2, V3. But I can't go back to V4 because there is no self loop in that one. So let's solve another problem related to this concept itself. So we will understand the problem much easier. So what are my vertices? V1, V2, V3, V4, V5, V6. So we should use all of them. V1, V2, V3, V4, V5 and V6. In this side also I must write all of them. V1, V2, V3, V4, V5 and V6. Now if we see here, from V1 there is direct connection to V3 and there is direct connection to V2. So none other than V3 and V4, there is no direct connection from V1 and there is no self loop for V1, so we will not include V1 also. So from V1 you can go to V3, from V1 you can go to V2, all others you can't move. Next, V2 if you see, V2 is having direct connection with V1, it is having connection with V3 and there is self loop for V2. So you can take V2 is also the another possible path. From V2 I can go to V1, from V2 with self loop I can go to V2, from V2 I can go to V3 and all others path will be 0. Now from V3 I can go to V1 directly, from V3 I can go to V2 directly, from V3 I can go to V4 directly. So what are my possible paths? From V3 I can go to V1, I can go to V2, I can go to V4. There is no self loop for V3, so you can't visit V3. So 0, 0, 0. Next, V4. So V4 is having direct connection with V3 and it is having direct connection with V4 and it is having direct connection with V5. So V4, V3 and V5 are my possible answers. V3 and V5. All others will be having 0. Now V5. V5 is having direct connection with V4 only. It is not having the connection with V6. It is having only connection with V4. So only V4 will be considered in this condition. Next, last V6. If you see here, V6 is not connected to anyone. It is a separate vertex and it is not having the edge connection to any other vertex. So write all the values as 0. So now you have converted the given graph into the adjacency matrix. Now let's find how to convert the given adjacency matrix into the graph. Now this is the second type of problem that can be asked under this topic. That is, draw the graph for the given adjacency matrix. The adjacency matrix is given right here. According to this, we will be drawing the graph. So first let's take the V1 vertex. So from V1, there is no connection to V1. So you can tell that there is no self loop. So there is connection to V2 because 1 is added here. So from V1, let's move to V2. From V2 and from V1 there is connection to V3. Let's take V3 right here. Now there is no connection for V4 and there is no connection for V5. So wherever 1 is there, you must be considering that one itself. If you see the V2 vertex, it is having one value for V1 and V3. So you can conclude that from V2 there is direct connection for V1 and for V3. From V2 there is direct connection for V1 and there is direct connection for V3. Next, V3 vertex. It is having one at V1, V2 and V4. So from V3 you can go to V1, from V3 you can go to V2, from V3 you can go to V4. Let me take V4 right here. Wherever you can take V4 here also. Now, let's take V4 here. From V4 you can go to V3 or you can go to V5. From V4 you can go to V3 and you can go to V5. I will take V5 here, you can take here also. Anyway you can take. Just keep it in mind. You must mark there is a relationship between the given vertices which are represented in the adjacency matrix. Now the last one is V5. So V5 is directly connected to V4 and V5. So V5 is directly connected to V4 and it is also connected to V5. So you can tell that there is a self loop. So this completes the problem which has been asked. So the first part was how to convert the given graph to adjacency matrix, and now we discussed how to convert the given matrix into the graph respectively. So hope you understood the concept of the adjacency matrix. If you have any doubt regarding this topic, please do comment below. The video link of the incidence matrix is given in description. You can access it. If you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.